So, good morning again. We're being late today just for internet connection error. And now we're going to start with our lesson. Till now I have 54 and it used to be 54, now 53. There seemed to be something wrong with your internet. Okay, miss. The first thing, rename yourself, write your first and your last name, and then if you're done, we're going to start with the lesson. Jad, what's your question before I start?
مش هلا للفاينل للفاينل
Yes.
هلا مش كاتبين على الماث انه بوكلت 20 وبوكلت 21 ال 21 تبعت الميكس براكتس.
Yes, 21 mixed practice.
19 يونت 19 مش حاطينها.
Unit 19 ليه بدهم يحطوها؟
انت حكيتي ديك المرة انه 19.1 و 19.2.
No, I said 9.1 و 9.2.
9 okay.
9, which we're going to start with it today.
okay.
Okay?
يعني كم درس رح ناخذ منها مش؟
Just the first two lessons. The last lesson, it will not be included for the final, but I will record the lesson and I will send for you the recording.
Okay.
Okay? After you're done studying the final, please look at the video.
ماشي. Okay.
Okay, you're going to need it for a grade 7. Yes, ya Muhammad Fuad, what's your question?
Teacher, we will have a quiz today.
Guys, do not ask me regarding this. Whether we have a homework, whether we have a quiz, and do not talk about the final exam. We're going to talk about the final exam on Thursday after we're done with our lesson. Today, I'm not going to talk about the final exam. If you have a question regarding the final, put your hand down. I'm not going to talk about it. If we're going to have a quiz, I'm not going to talk about it. If we're going to have a homework, the same. Yes, Wasfa.
Teacher, the final exam, everything is included.
One more time, I mentioned, yeah, Wasfa, I'm not going to talk about the final.
Okay.
Yes, Masa.
Teacher, is Thursday the last class?
Yes, Miss, Thursday is the last class. Now let's start with our lesson. So our lesson today will be the first lesson in chapter 9, and it's about collecting like terms. Now, chapter 9, it's the actual introduction about algebra. We did actually start using the terms of a variable and translating algebraic expression in chapter 2, but how we're going to use them actually, we're going to use them in chapter 9. How do we actually solve a linear equation? That's what we need to reach at the end of chapter 9. So the first two lessons will be about simplifying algebraic expression or simplifying equation. The last lesson, which is not included in the final, will be about how do we solve linear equation. So our objective for today, the title for our lesson is Collecting Like Terms. So all of you open your course book, page 98 and 99. Our objective, we only have one objective, simplify linear expressions. We have two ways of simplifying, either collecting like terms, which is our lesson today, or multiply a constant over a bracket, which is our next lesson, which for Thursday, and our last lesson as a live session. Okay? So let's start with the first one of simplifying, which is collecting like terms. Now, before I start with this, we have something called Sameness Slope. The Sameness Slope says that if you have two things that they have the same name, you can actually add them. So if I said in grade 6D, I have two students that have the same name, which are Ahmad Nasser and Ahmad Rabia. So if I ask how many Ahmad do I have inside the name Ahmad inside 6D? I would say 2 Ahmad. I can add them because they are the same name. If I say how many Kareem, close your video, ya Masa. If I say how many Kareem do I have in 6D, I would say I have 3 Kareems. Why did I add them? Because they are the same name. But can I say, if I'm adding, let's say, fruit right now, and I have 2 apples and 1 banana, how many do you have? Will you say you have 3 pineapples? Will you add the names? Or you're just going to say 3 apples and 2 banana? You're going to keep the names. For what I know that I will keep the names because it doesn't make sense to say pineapples. Okay? So if I have different name, I'm not going to add. I will keep the numbers the way they is with their names. But if they are the same name, like Ahmad and Ahmad, I can actually add. But once I say the family name, I cannot add them. I will say I have Ahmad Nasr and I have Ahmad Rabia. Okay? So if I do have this example, which is written in your book, here we have 2 different breaks. Okay? A break is a block. The first one is, the length of it is X, which is the red one. The second one, which is the blue one, the length of it is Y. Now, what's the total length of the one that I draw it beneath or below? Can I say I have 5 XY blocks? Can I say this? Do you have 5 actually? Are they the same measure? Are they the same name? Or you're just going to say I have 3 X's, 3 red blocks, and I have 2 blue blocks or 2 Y. What is the best one? Or not the best one, the correct one? Because they have different name, you're just going to say I have 3X and 2Y. I cannot join them together by saying 5. The same goes as I said for apples and banana. I couldn't join them. I kept saying I have the how many apple and how many banana. Why? Because they have different name. So here, I do have 3X. The X's I can add them. I will say I have 3X. Because I will count 1, 2, 3. 3 blocks, so 3 X's I have. For the blue alone, I can add them. They are the same name, so Y plus Y is 2Y. But for both of them together, I cannot add them. So I will just say it's 3X plus 2Y. What's the value? I have no idea. That's the value that I can deal with it. More than this, I can't. Okay? So before I move, all of you open your book. We're going to solve question 1. Okay? But before I start with the question 1, do you have any question? Yes, Yamasa. Okay, you lower your hand. Now, let's start with the question. Question 1 only we're going to do. So the blocks are, I draw them here in front of you. We have a yellow one, which is A, the green one, which is B, and the blue one, which is C. In A, this is the figure that they draw it. So let's start. Masa كانت أول واحدة رافعة إيدها. Yes, Masa. What will you say the answer for A?
4A.
4A, thank you very much. That's it. Now let's move to the next one. Now, Amir.
Yes,
Let
teacher.
me just put the graph. Yes, yeah, Amir, what's the answer?
3B.
3B, excellent job. Now, next one, Jude.
2A, 1B.
You say 2A plus 1B. The word and, Jude, means plus, okay?
Yes.
And we cannot write as a mathematical answer and, we need to write an operation. So what will I write? I will write a plus. So as she mentioned, 2A plus 1B. But is it a must to write the 1?
No.
No, thank you very much. By the way, why it's not a must? Because 1b, it means 1 times b. And 1 times anything will say the same value. Julie, next one. D.
2C and 2A. 2C plus 2A.
Excellent job. 2C plus 2A. Now for me, and later on you're going to do the same, but not right now. Later on, when you master the concept, it's preferable and it's much more better to put the answer in alphabetical order. What do I mean? Not to write 2C plus 2A, to write 2A plus 2C. It doesn't matter. It's exactly the same answer. But we prefer to write in alphabetical order. Okay? Now, next one. Yes, يا معروف.
3A plus 2B.
3A, excellent job, plus 2B. And he already wrote them in alphabetical order. Thank you very much, يا معروف. Now, next one, Kareem. The last one, actually. Kareem Bdair. Kareem, I'm waiting for your answer. Kareem. Okay. Someone else other than Kareem? Yes, yeah, Qais. Qais, what's the answer?
2C plus B.
If I want to write it in alphabetical order,
B plus 2C.
excellent job. B plus 2C. Thank you very much. So right now, why do you think I cannot add the B and the C? And what do we call them mathematically? Mathematically, we call B and C unlike terms, okay? And when I have 3B, B and B, and another one, that means they are like terms. So what's the actual definition of like terms? Let's look in the next slide. So what do I mean by like terms? Like terms are terms whose variable and exponent are the same, exactly the same. So I have two conditions. The variable should be the same and exponent should be the same. The exponent is the power. In x squared, what's the exponent? 2. What's the variable? X. Okay, so if I want to say that two terms are like terms, they should have the same variable with the same exponent. But what do I actually mean by a term? Some of you, they're going to ask this. Before mentioning what do you mean by like terms, what do you actually mean by a term? Do you remember when we used to deal with sequences, I used to tell you this is term number 1, term number 2, term number 3. This is what do I mean by a term. Now, in an expression, we have much more detail than this. A term is a combination of numbers, variable, and only two operations, multiplication and division. If you have extra, that means it's a new term. Look at this example. I have this expression in front of me. I will start looking. How many terms do I actually have? I actually have 1, 2, 3, 4, 5, and 6. Why did I say I have 6? This one, 5x, it's a combination of a number, a variable, and the operation is times. So this is your first term. Now, once you have addition or subtraction, that's the end of your term. So here, this is the end of my term and the beginning of the new term. This is the end of my term and the beginning of the new term. This is the subtraction, the end and the beginning for the new term. The end and the beginning, I don't care about the multiplication. It's still in the same term. I don't care about the division. I'm still within the same term. Here it's a subtraction that's the end of the fifth term and the beginning of the new term. So how many terms do I actually have? I have 6 terms because the term can contain inside it a number, a variable, and multiplication or division. If you have addition and subtraction, it's a new term. Let's look at this example. How many terms do I actually have? Who can answer? Mu'taz, how many terms do you have?
1, 2, 4.
Excellent job. 4 terms. Which are these? This is x squared the first term, 5x the second term, 2x over y the third one, xv the fourth one. Now let's move to another example. Now, Omar, Zaidan, in this example, how many terms do you have?
4.
4 terms. So I have x squared, 4x, 8y. Now for you, when you're looking at it like this, you're going to say 4. Later on, you're going to change your mind. But right now, it is correct, it's 4. Right now, what do I mean? If we know what do we mean by a term, what do I mean by like terms? Like terms, they should be the same variable with the same exponent. So if I'm looking at the first example, which is this one here, I have two terms that are like terms, which are what? The first one is actually this one, and the second one is actually this one. Why are they the only like terms? Because they have the same variable xx, and the exponent for the x, even if it's not written, it's 1, because the only exponent that I don't write is the 1. So these are like terms. But the rest of them, they are not like terms. Why? Because this one has bt. None of them, they have bt in the same time. 8xmn, it has x, but it doesn't have here 5x, it doesn't have mn. So you can't say 5x is the same as 8xmn because the name here is xmn, okay? This one and this one it has only m. This one here, it has xmn. This one has only m. So we cannot say they are like terms. xmn and here wm, they have only common m, but they don't have the rest. So the only two terms that are like terms is x and 5x. I do not care about the number. The number that is beside x, we call it coefficient. And I don't care about the coefficient to be the same. I only care about the variable. So one more time, what do we mean by like terms? Like terms are terms whose variable and their exponent are what? The same. Regardless the number. I don't care about the numbers. Let's look at the second example. In the second example, do you have any like terms? Jad, do you have any like terms here?
Yes.
Where are they, if yes?
5x.
With what?
2x.
Wrong. Because 2x over y, it has two variables, x and y. Do you have in 5xy?
No.
So that means they are not like terms. What else?
xv. لا ما في.
So in the second example, I have no like terms at all. Okay? Now let's move to the third example. Omar Ma'touk, do you have any like terms in the third one?
Yes,
Which are what?
x and x.
X and 4x. So this one and this one. X squared and 8y, they are not like terms. Thank you very much. Let's have another example. But before that, What did I mean by coefficient? As I mentioned, it's the number that is multiplied by the variable. And it could be different, I don't care about it. Now, in this example, if you're looking, I have 3 like terms. Why they are like terms? The variable is x in the first one, x in the second one, and x in the third one, regardless the numbers. Even though the numbers, the coefficient are different, but because the variable and the exponent for the variable are the same, that means they are like terms. Let's have another example. This is the same example. Here's the other example. Are they like terms? Who can answer? Yes, ya Fuad. Muhammad Fuad. Muhammad.
No, they
Yes.
are not.
They are not. Why do you say that they are not?
Because the last one is y2x, not xy2.
Did I mention the order matter? It's multiplication at the end, Muhammad. xy squared. Isn't that means that it's x times y squared?
No,
Why not? We said that if they are beside each other, that means the operation is times. We said it previously. So for example, negative 3x, it means negative 3 times x. Didn't we mention that?
yes,
Okay, so 8 over 15 xy squared, it means 8 over 15 times x times y squared. Isn't that right?
yes.
And in multiplication, does the order matter?
No,
If I say x times y squared or y squared times x, doesn't matter?
no,
No. So are they actually like terms?
yes,
Yes. Why is that? How do you check? You're going to look, I have x in the first one. Okay? Let me show you how do I check. Even me as a teacher, this is how I check. I have x in the first one with exponent 1. I have x in the second and with exponent 1. I have x in the third with exponent 1. It doesn't matter what's the order of it. Now I will move to the next variable. In next variable, y with exponent, or let me change the color. Y with exponent 2. Let's look at the second one. Y with also exponent 2. Till now they are the same. Y with also exponent 2. So I do have x with the same exponent, y with the same exponent, and the 3 of them together. So they are actually like terms. Okay? Is it clear till now?
yes.
All of you, put your hands down. I want all of you to lower your hand. All of you lower your hand. Before I move to the next part, raise your hand if you have a question. Yes, Yanur.
Teacher, I didn't understand.
Which part of it?
Why, how, what should, the answer should be?
What the answer should be, we're going to discuss it later on. Now the answer is, I'm only asking you, are they like terms or are they not?
Okay.
Okay, so how do you answer me with yes or no? By checking the variables.
Okay.
They have the same variable with the same exponent, and not only one variable, all of the variables. Are they all of them the same variable with the same exponent in all of the terms?
No.
If the answer is yes, then they are like terms. If the answer is no, then they are not. Okay? Yeah, let's have this example to show you what do I mean by unlike terms. Let's look at this one. When we're looking at this one, They are not like terms. We call them unlike terms. Negative 3xy, negative 3y, negative 3y squared. Why they are not like terms? Because the variables in the first one, let me clear the drawing. The variable for the first one is actually what? xy. Now go to the second one. Does it have x? It doesn't, which means it's not like terms with this one. So these are not like terms. Now, do we have x here? Also, we don't, which means that this one is also not like terms with the first one. So I'm done. The first one has no like terms at all. Let's compare these together. Now, let's look here. This one, it has y, and this one also has y. But is that it? Did I finish all the conditions? I still have another condition. They should be the same exponent. Here the exponent is not written, but it's actually 1. Here the exponent is 2. So are they the same exponent? The answer is no, which means they are not like terms, okay? So if I'm only asking you, are they like terms or not? This is what you need to check. Same variable, same exponent. Now, I hope it's clear, Yanur. If not, raise your hand again. Ahmed, what's your question?
Teacher, I didn't understand the like and unlike terms.
I'm repeating, yeah, Ahmed. What did I repeat right now? You have 2 conditions to check them. The first condition, you need to check the variables. Are they the same?
No.
When I'm looking at this example, look at the third example, this one. 2x. What are the variables that you have them here?
2 and x.
2 is not a variable, 2 is a number. I don't care about the numbers, I only care about the variables. The letter. Okay? What's the letter here? X.
Teacher, what?
The letter, the variable.
X.
X. Now, do you have x alone in this one?
No.
Do you have x alone in this one?
We have y, not x.
Excellent. So till now, do you have a like term to this one, the one that I put a circle around it?
No.
The last one, does it have only x?
No, it has x and y.
X and y. So that means I don't have any like terms with 2x because x is the only variable that I have it here.
Okay,
if I'm looking at this one, I have x squared, not only x. So the variable is x, but the power is a square. So does this mean that it's like term with the first one?
No.
No, because the powers are not the same. Does this mean it's the same as this one?
No.
2xy?
No.
No, why?
Because the x has the 2 above it, and the second one has y.
Excellent. Thank you very much for this explanation. So right now, is this clear?
Yes.
Okay. If the same question as Ahmad and Noor, I'm not going to repeat. If you say you don't get it, I'm also not going to repeat. You can watch the video one more time by yourself. Yes, Masa? Okay. Now let's move to the next example or the next procedure. Yes, Masa, what did you want?
Why do we need to see if the other terms need to be the same as the first term?
You're going to know later on. Right now, you're going to know why.
Okay.
Okay. Now, why do I actually need them to be like terms? Why do I keep insisting, are they like terms or are they not like terms? Because our objective, as I mentioned, is to simplify expression by either collecting like terms or expanding the brackets. Expanding the brackets the next lesson. Now, what do I mean by collecting like terms? Is to actually add or subtract the terms that are the same, or the terms that are like to each other. So, and what do I actually add is the numbers that are beside them. That's why we write the numbers. We don't care about the numbers to know whether they are like terms or not, but I care about the numbers to add them or to subtract them. So the first question I will ask myself when I want to simplify the first example A, are they like terms? I have x with exponent 1. I have x with exponent 1. Because they are like terms, what can I do? I can add what? The coefficient, the numbers that are beside them. So what will you do? You're going to say 2x plus a 3x. What's the answer? You just add the 2 and the 3. 2 plus a 3 is actually what? 5. You're going to say 5x. And you do not change the name. Why? Because it's the same as fraction. When we used to deal with the fractions, if you do remember, 1 over 3 plus 1 over 3, let's say, you do not add the denominators, you only add what? The numerator, and you keep the same name, because the name here is third. So this is 2/3. So my name is 1/3. Here my name is x. So I keep the same name. Now let's move to the second one. In the second one, I will double check y with exponent 1, y with exponent 1. They are like terms, which means I can add and subtract. What do I add and what do I subtract? Only what? The coefficient, the numbers. So 7 minus 2y, the answer will be what? 5y. Let's look at the third one. I have 4 terms, and not all of them are the same. So how can I start, or what should I do first? You start by underlining the like terms with different way of underlining. So this one is what? 4p, and this one is 2p. And by the way, I underline it with the sign that is before it, not the sign that is after it. Now, why are they like terms? Because they have the same variable with the same exponent. Now, what do? I actually add the 4. And how did I know it's addition? Because the operation before it is what? Plus. Okay? So what will you do? 4 plus 2, which is 6p. Now, what about the other one? I will underline it, but with 2 lines under it, to know that this one, the Q, is different than the P. And with what? With this one. But you do not have a number. What's your number going to be? Can any one of you tell me what's my missing number? Sama, do you know what's the missing number?
No.
What is the number, ya Sama, that when you multiply it by anything will give you the same number you start with it?
1.
Thank you. So what is the missing number?
1.
Thank you very much. So if
You're
you
welcome.
don't have a number, you put 1. And it's actually 1, but the 1 we don't write it because we do know it. We know that the coefficient is always 1 when I don't have a number, because it's the only number that will not change the number next to it. Okay? So what will I subtract? 3, positive 3, and negative 1. Now, some of you, they will tell me, what should I do if both of them are negative? You need to go back to the negative signs. How did we deal with them? Put the head in a plus if you forget about it. So if I want to put the head in a plus, this is revision, has nothing to do with the lesson. I can put the head in a plus right away here. So positive 3 plus negative 1, they are different signs, so I can find the difference. But here I don't need to do that. I can just subtract. 3 minus 1, which is what? 2q. So the answer for this is actually what? 6p plus 2q. Let's move to the last one. Who can do the last one? Let's check وصفة. Can you do the last one, وصفة?
5t plus 7 minus 3t plus 3.
Mm-hmm.
5t,
Mm-hmm.
we'll add it, we'll subtract from it 3t.
Excellent job. So it will be what?
2t.
Uh-huh.
Then 7 minus 3 plus 3.
No, not 7 minus 3. 7 is what? Positive.
Positive.
And the 3 is also what?
Positive.
So what do you do when they have the same sign?
Add.
Add them. So 7 plus 3 is what?
10.
10. So the answer for this will be what? 2t plus 10. Okay? Now, before I move to the next example, put your hands down. All of you, please put your hands down. Even if you have a question, just right now, all of you just put your hands down. Okay, now raise your hand if you have a question. Yes, Ya Rayan.
Teacher,
Yes.
can we find the answer if it's just if they are different names, like
2t plus 10. Can I continue? What again?
Yes.
No, you cannot continue further, Ya Rayan. That's it. If you continue, it will be wrong. Okay? Yes, Khawaja.
Teacher, we have to write our names because.
Just start writing your names.
Okay.
Oh, it's closed. I open it for you. You can start writing your names. Now, Mira, what's your question?
Teacher, in the example in C.
Yeah.
How did you know that it is like we minus and then we subtract?
Because the sign of Q is negative. Now, whenever you're dealing with expression like this, Mira, and the rest of the class, the first step, do it. Before any subtraction, put the head in a plus. And if you don't have a number for the variable, put 1. So if I want later on, this is the instruction that I was going to give it to you later on. Before you even start doing anything, you're going to put the head in a plus at the beginning. So here I should put the head in a plus. 7y plus negative 2y. But it was obviously that I should subtract. Where the confusion will be when we have like C. So here plus, I don't care. Plus, I don't care. But here minus, I will put the head in a plus. Now here it has a number, P. Here it has a number. A number here I will put 1. So you need to do 2 things before you start. Before any subtraction, put the head in a plus to know what's the sign. And if you don't have a number, put 1. So here I'm going to put the head in a plus. So in this case, I will know what should I do, add or subtract. Is it clear now, Yamira?
Yes.
No. Yes, ya Mu'taz.
If there were two names and when we if there are 2 names and we find the answers, do we have to put a plus sign between them?
What do you mean? Are they the same name or are they different name?
Different.
No, you should put a plus between them. You cannot actually add them, ya miss. This is what we did. Because 6p plus 2q, are they the same name?
No.
So can I add them?
No.
So which means you need to keep the plus. You cannot take off the plus. If you took it off, you're going to change everything. Because when I don't have a plus and you write it like this, yeah, Mu'taz, let me show you the way that you're mentioning it. 6p2q, what do I know? And what do you know about the variables that are beside each other? That the operation between them is actually what? Multiplying. No, not a plus. That's why we keep the plus. If we took it off, you're going to know that it's a multiplication. You change the whole operation. Is it clear now, ya Mu'taz?
Yes. Do we sometimes put a minus between them?
Yes, you can. It depends on the sign. Here, I didn't have a negative sign, so it doesn't matter. It doesn't matter. It do matter, but I don't have a negative sign. So why should I put it? Okay.
Okay.
Now, Mansour, what's your question?
Teacher, can we have decimals in the expressions? We can only have whole.
What did you saw at the first examples that I mentioned them on the board, on the screen? Mansour again.
Oh, yes.
I did put negative numbers, I did put decimals, and I even put fractions. So I don't care about the number, what is it? What's the way it's written? Wasfa, what's your question? Wasfa. You raise your hand, what's your question?
In C, why didn't we write it as PQ?
What should I write?
Why didn't we write it 8PQ?
Because are they the same name, ya Wasfa?
No.
Can you add them then?
No.
And stop laughing around and focus on the lesson. Noor. Nuruddin. Yes, Noor, what's your question?
I didn't understand this part. And do we have homework today?
You have a homework today, and which part you didn't get it, ya Noor?
This.
Which one of them? I did 4 questions right now.
C.
See, miss, I'm looking at the like terms. Where are the like terms that you see them?
4P and 2P.
So add them. What's the answer for them?
6P.
طب Q, is it like terms with P?
No.
Can you add it?